I have a couple of people out testing right now for the ISEP, so we're going to go ahead and record it. And we'll start with the idea of a spherical mirror. I've got to run it in show mode, so I'll just show you this. So you have to imagine like that. When yesterday I had this picture of this globe here. So we have a sphere. Are you in, guys? Are you guys in the canvas? In Zoom? Okay, sorry, I forgot to tell you all to join. So let's take a glass sphere, such as this one, and then we're going to look at it, and we're going to take and actually just cut a chunk. And so we have this piece of the mirror. If I look at it from the inside, it's an inside curve. It's called a concave mirror, as if it reflects inside the ball. If it reflects outside the ball, the outside shape is called convex. And so that's just some language. There is a point in the middle of the sphere called the center of curvature, and that is a construct we'll use. And then there's the principal axis, the line that goes through the diameter of the ball. So we're going to take our mirrors and pretend then that they are parts of a sphere. And then we'll identify that dot as the center of curvature. And then half the distance, and this is a definition, half of the distance from the center to the edge is called the focal point. And we'll label that with an F. Okay. So we go on to the next picture here. So here's a concave surface. The center would be over here somewhere. It's not labeled in this picture because it's just zoomed in too big. So if I have light coming from, for example, the sun, they're essentially, because the sun's so very, very far away, the light coming from the sun is parallel. And any parallel ray that hits a concave mirror will reflect out and travel through that point I call the focal point, where I labeled it F. Okay. The distance from the mirror to that point F is called the focal length. And we write that with this scripted italics F. All right, so again, this is a concave mirror. Light rays that are parallel come in and always exit through F. That's one of the principal ideas. Okay, and I've got some other things. I'm going to show you some drawings here in a minute. And then we have a convex mirror. So here's the mirror surface. It's convex. So again, the light from the sun travels into the mirror parallel, and it reflects out. Notice all the outbound rays are in different directions. If you extrapolate them behind the mirror, they look like they would have joined at F, the dotted lines. So a concave mirror will actually focus parallel lights to a single point in front of it, and a convex mirror will defocus the light, but it looks like it would have been focused behind it. All right, so that's a distinction, and these all follow the law of reflection, and I'll kind of highlight that in the presentation I've got here in a moment on the next slides. So that's it on the PowerPoint slides. Now let me switch over here. I'm going to deal primarily with the concave mirror. So I've got it drawn. Make this large so I can see it. So what I've done is I've taken in Word and I've drawn a circle and hidden part of it. So I've got what I'm going to call is a chunk of that mirror. And so light ray 1, and this dot is the C. And half of the distance to the dot is the focal length. So I'm going to measure that right now. That is just over, I couldn't have made it 5 centimeters, could I? It could have been nice to be exact. So just over 5 centimeters, so just at 2.5. That spot right there is the focal point. All right. So we've got a light coming from out here, and the classic way we do this is, I'm going to just do this. I'm a little bit lazy. Well, actually, let me just try it. There are 3 rays of interest. 3 rays of interest. Any light ray, as I showed before, that enters, and this line is called the principal axis. I'll label it as PA, and that's just the one that goes through the center. Would have been the diameter of the sphere. Any light ray that runs in parallel to the principal axis. This is the definition of line number 1. Any light ray that runs in parallel to the principal axis. I'll just draw one randomly here. I'll try a longer ruler, but that's what I've got. That's okay. Any light ray that runs parallel to the principal axis, when it hits the mirror, will reflect off and come out, by definition, through the focal point. So I'm going to go through the focal point. So that is the possibility. So if it's coming in parallel to the principal axis, it will exit out through the focal point. So we'll call that one line 1. Okay. Line 2, any light ray that passes from any angle and goes through the center of curvature before it hits the mirror. This is just a rule. Any light ray that does this goes in, hits that center. Where it hits the mirror, it by definition, because this is a radius, it will by definition be perpendicular. And so any light ray that comes in through the center of curvature will also come out through the center of curvature. Just bounces in, bounces back out. Okay. And then my third light ray, and I'll do this from another angle. This is not how we draw an image. I'm just showing you the 3 rays. So my third light ray, any light that passes in through the focal point. So it passes in through the focal point first, hits the mirror. So it's coming in this way. This is line 3. It will come out and will be parallel then. Its exiting ray will be parallel. So I'm going to measure this distance down so I can kind of cheat. That's about a 1.2. So I'm going to come back here and mark a 1.2 centimeters down. So get a line here. So any light ray that comes in through the focal point will reflect off and exit out. And this is all following the law of reflection. Reflect out parallel to the principal axis. So that's supposed to be a parallel line. So this is line 3 exit. All right, so line 3 in, line 1 in is red, line 2 in and out is green in this picture. And so all light rays, we're going to see this over and over and over. We'll use these 3 drawings to identify how and where an image is located. So light ray 1, I'll make a note here, light ray 1 is in parallel to the principal axis, out through the focal point. Okay. Light ray 2 in through point C, which is the center of the curvature, comes out through point C as well. And then line 3, if the light ray comes in through F, it will move out parallel to the principal axis. Okay, so that's the generic version of this picture, and we'll refer back to these 3 lines and use them. So now let's take another drawing. So I've set up the same thing, and this time I'm going to place as an object. I'm going to use an object here. I'm going to place an arrow here. And define some things here. The height of the arrow is referred to as the height of the object, HO. The distance from here, from the mirror to the object, that distance, which is 14.4, would be DO. Okay. And so I'll make a note here. DO is the distance to the mirror along the principal axis. That's this line across here. So we're going to draw our lines. And again, line 1 in parallel. So I'll do it in red just like before. Line 1 is in parallel to the principal axis. And so I don't even know how tall I made that. So I need to kind of measure it. Just under 2 centimeters. So I'm going to just under 2 centimeters. So it goes in parallel to the principal axis, to the mirror. So light ray 1 goes in parallel to the principal axis, and it reflects out through, oh, I didn't find F. It reflects out through F, so I've got to get F here. Sorry, I didn't mark it. That's F. Line 1 in parallel to the principal axis, out through F. So I just draw it like that. It goes in, that's line 1. Line 2 was green on the prior drawing, so I'm going to go back to line 2. That is the line that goes in through C. It hits and is perpendicular to the mirror, so it comes back out through C. It goes in through C, hits the mirror, comes out perpendicular, so it is both in and out through C. The third line, it goes in through F. All right, so it's kind of between these two. If you look at where it is on the back end, it goes in through F, reflects out, and comes out parallel to the principal axis. And if you can see, those 3 lines cross right here. The exiting rays. Where the exiting rays cross is the location that the image will appear. And so the image here will cross, and it's, notice, underneath the principal axis. So it's actually going to be upside down. And so we draw the 3 rays, just like I did in the sample. So we had in parallel, and I did it the same color. So line 1 is in parallel and out through F. In parallel and out through F. Line 2 was in through C, out through C. I did that in green, so I'm going to label that as number 2. And line 3 was in through the focal point and out parallel. So lines 1, 2, and 3, where they cross as they exit the mirror, will show me the location of the image. Okay. What I can do with this, if I look at this distance here, the height of the object is how tall the object is. It's labeled as HO. The image has a height down here as well, right? So it's going to have an HI. So this distance here is HI, the height of the image. And the distance from here to the mirror is DI. So HI is the height of the image, and DI is the distance from mirror to image along the PA, the principal axis. Okay, so this image forms in front of the mirror, and by the definition of what I did yesterday, this would be a real image, and it would be inverted. The image is clearly smaller than the object, so it would be reduced in size or demagnified, and some parameters about that. So just today, we're just learning to draw and think about curved mirrors. So if I move the location of this image somewhere else, what happens to the location of the, excuse me, remove the object? What happens to the location of the image? So let's take a picture of that. So this one, we can see the object was actually kind of far away from the mirror. And so now I'm going to actually move it in. Let's put it actually right here. Let's do it in black so it can stand out better. A fixed object. So if I put the object right here, I don't know how tall I'm making it, but it is what it is. So the object is at the center. The focal length is still need to be identified. So that's again about 2.5. So using the same 3 lines, if I can do them, line 1 goes in parallel, so I need to measure the height of that object. We're going to call it a centimeter. And line 1 is a red line, a centimeter tall. Mark it. Line 1 goes in past the top of the arrow, hits the mirror, and stays parallel to the axis. So it comes in. That's not a very good parallel. That's very good. My eyes are better than that. Okay. In parallel, hits the mirror, reflects off, and comes out through the focal point. So line it up, comes out through the focal point. Okay. So that's line 1. Line 2, I said, goes in through C, out through C. Well, this is point C. I can't do that line on this picture because the object is at point C, so I can't go through the top and point C. So in this one, I'm going to skip the second line and go straight to the third line. It goes in through the focal point. Hits the mirror and reflects off and comes out parallel to the principal axis. I'm not very good at drawing parallel right now, so hang on, give me a second. I'm guessing a little bit here. It's not a good guess, but it's a guess. So if I'm at the center of curvature, it so happens that the image is where it crosses, and 2 lines is enough, and the image is actually going to be pretty much right at the center of curvature as well. I had some errors in my measurement, but that's what we're going to see. So we can actually use, again, 2 lines. So lines 1 and 3 will work. Lines 1 and 2 will work, but it takes at least 2 lines with exiting rays to identify the location of the image. What if, I'm going to do one more drawing and we're going to call it done. So what if I now move this thing in? I'm going to move it in way in here. This one's, actually I can't do it because I didn't draw my picture very well. Yeah, let's tell you what, I'll do one between F and C. So let me mark my center point. Here's my focal point. That's the focal point right there. So let's put the object right there. Okay. And where's the image going to appear now? So this is C, this is F. The object is between F and C. So to figure it out, okay, first I'm going to measure how tall that is. Again, right at a centimeter to touch over it. So I want to go in, I'll come down here so I can get my line just a touch over a centimeter. So I'm in parallel to the principal axis. Out through the focal point. Okay. And I said in through C, out through C is line 2. So the light ray comes in through C. It does hit the object after it hits line spot C, but that's fine, but it's still perpendicular. So it still reflects back on itself. So it goes in and out on this line. And notice they cross out here. I could stop here. And in fact, I think I will, just to make it a more informative piece of ideal here. So the image will be where those 2 cross. It appears to be about here. So in this case, this is the object, and this one is the image. It is upside down. It is bigger than the object, and so I've magnified it, made it bigger. And so there are some parameters, and we'll go through some practice sheets for this. I'll post something for you guys to try this yourself. So the idea is that we have our 3 lines that I want you to be able to draw. If you can't draw because of a location, that's fine, but any line that goes in parallel to the principal axis will come out through F. Any line that goes in through C will hit perpendicular and come back out upon itself. And any line that comes in through the focal point will reflect and come out parallel. And so you're going to use these 3 lines every time you do a drawing. Okay, that's all I have for today. It's long enough. Anybody have any questions?